am filming, obviously, with my wet, undyed hair. That's going to get worse as these videos go, so don't judge. My husband keeps saying, "Are you dressing up for these videos?" I was like, "No." He goes, "Shouldn't you put work clothes on?" No. I barely put work clothes on to go to work. Never mind now. You'll see every pair of sweatpants that I own. Okay, 3.6, measures of spread. Oh, let me turn my heater off. A little bit loud. Measures of spread. So this is the next section of how we're going to analyze the data. So just remember that Chapter 3, Statistics, is all about gathering data by means of a survey. So how is the best way to gather data? How is the best way to keep it bias-free? Once I have the data in my hands, what do I do with it? That's where the lessons that I'm starting right now come in. So 3.5 through 3.8 are all dealing with the mathematics of what's going on. So once you have data in your hands, how do you analyze it? How do you come up with statistics that you can then use in a study? So what's happening in the world right now really is highly statistics based. So they're taking a bunch of data and looking at things like what percentage of people are being hospitalized due to COVID, what percentage of people are needing to go into ICUs, what percentage of people that are sick need to get ventilators, what percentage of people are passing away, and they're really looking at huge sets of data. What percentage of people are being tested? What percentage of people are having no symptoms or asymptomatic and going around? So there's a lot of data that's being driven right now, and you should be a little bit cognizant of how that data is being given to you and sort of, you know, its importance. It has a little bit of a weight factor. In the last couple of days, the way that Canada and America has presented data has been starkly different. Yesterday, what day is it today? Today's Thursday. Yesterday, Wednesday, America straight out said that they, based on the curve they're on right now, they're expecting at least 100,000 people to die. In an interview with local officials, provincial and federal officials, Canada just said it was a grim outlook. They don't want to put numbers on something that causes panic. So it's a different way to address things, in a different sense, maybe a sensationalization of what's going on, but maybe people need to see those numbers so that they follow the rules. We're all staying home. They wouldn't make us stay home from school if it wasn't serious. So we're doing the best to get you guys to graduate and to get things through. But realize you should come out of this course with a little bit of a better understanding of numbers that are being thrown at you from the media, and maybe trusting them less or more. It really depends on the situation we're in. Okay, measures of spread is coming after measures of central tendency. So measures of central tendency wanted to say, how do they tend towards the center of the data? Okay, and we looked at mean, median, and mode in all of those scenarios. Let me just get rid of this sun that's coming in. Where it's coming from. I don't think I can get rid of it. Okay, so those are measures of central tendency, mean, median, mode. How does it get towards the center? Now we want to look at something called a measure of spread. And basically this is the big definition for what does it mean to be a measure of spread. How much does your data fluctuate around the central value? Now, what does it mean by central value? Well, it depends. If you're finding a range, that's just going from highest to lowest. No big deal. Interquartile range is going to be the central value that we're going to be dealing with is the median. How much it goes around the median. Standard deviation and variance are going to be the second thing, and those are going to say how much it goes around the mean. So it all depends which measure of central tendency we want to see, whether it's how far it's fluctuating around. So range is just highest minus lowest. You knew how to do that in elementary school. Interquartile range, which I'll refer to as IQR from now on, is seeing how much the data fluctuates around the median. Okay, same with semi-interquartile range. I'll give you the definitions of those in a second. Standard deviation variance, much more difficult analogy with these, is seeing how much it fluctuates around the mean. And this is probably the most powerful one that we're going to use. This is used less, just like median is used less. Mean, standard deviation variance, very powerful. Any statistics course that you'll take in university, you'll be calculating these again. Okay, so if you're going to take anything forward, standard deviation is one of the things that you're going to calculate for sure when you take a stats course, and you'll all have to take stats courses at some point. Okay, so the very first example, it just wants to see exactly how powerful this is. If you have two sets of data, I don't even know what these are. Imagine people's marks. Okay, someone has a mark of 44, 59, 70, 88, 91. This is a huge range of data. People's marks go from 44 to 91. Okay, you're talking about almost 50% difference from the highest to lowest. The range is massive. Then you look at another set of data, 5 other marks, 62%, 65, 70, 73 to 74. Okay, in this one, the range is only 12%. Okay, this data is tightly grouped. This is very spread out. Okay, that's what we're looking for, the measure of how spread out it is. Now, if you just find an average here, the average of these marks, 70.4. The average of these marks, 68.8. Okay, they look like they have the same average. Median, 70. That's the middle value, right? These are both written in order. The median is 70 in both of them. So if you only looked at measures of central tendency, you'd be like, great. They both have an average around 70. They both have a median 70. Perfect. We can take either of those. You publish those marks and say, look how great my class is doing. They have an average of 70%. Then you go, oh, what about these people? They're not doing so good. You know what I mean? Like, so it sways you. You can't just look at an average and say, oh, that data's great. No. If these were two different classes, what would you be happier in? Would you be happier in this class, or would you be happier in this class? Well, this class on average, I shouldn't use the word average. If you look at this class, they have what we would consider consistent marks. Okay? Everyone's mark is around the same thing. That means everyone is achieving basically at the same level. In this class, something is going on. Why are there people doing really, really well and people doing really, really poorly? Now, this is a small data set, so this could just be, there's a couple kids that aren't trying or aren't necessarily good at this subject, and a couple kids that are really good. Okay? Whereas the other class might be more consistent. If you had a huge set of data, and remember, one of the things for good data is that you have a large enough sample size. 5 values is not a large enough sample size. Okay, so you'd want a bigger sample size. So on something like this, just be aware that the measure of central tendency does not tell you the whole picture. That's why we need measures of spread. We need measures of spread to tell us more about what's going on. Okay, so we are going to look at specifically range, highest minus lowest. You got that. Cross that off our list. We are going to look at these two things. Interquartile range, and with that comes something called a box and whisker plot, the first sort of graph that we're going to look at, and standard deviation and variance. So I'll do sort of an example of each, and again, the notes are posted. You can see a better example through there. And then that'll be the end of 3.6. Okay. So interquartile range looks like this. Because it is associated with the median, in order to do an interquartile range, you have to list the data from, there will be a low point, all the way to a high value. Okay, so lowest value here, highest value here. In the middle is what we called the median. Okay, I am now going to relabel the median, and we're going to call it Q2. And the Q stands for quartile, and you'll see what I mean when that happens. Now you look at, this would be considered the low half of the data, right? This would be considered the high half of the data. And the next thing that we want to look at is what is the middle value of each of these. So the middle of the low part of the data, if we take the low half of the data and we find the median of this part, so this is really a median of low half, we're going to call that Q1. And then we do the same thing over here. This is the median, okay, or the middle of the high half of the data. And we are going to call that Q3. So at all points, you're going to basically, if you are ever asked to find the interquartile range or the semi-interquartile range, you are going to have to, let me just move this way a little bit. Morgan, can you make sure that's still, well, can you still see that when you look in the camera? Actually, just hold on. Morgan.
Yes.
Okay, you can still see it? I'm just going to shift it this way a little bit. Is that better?
Well, you can see that.
But can you see this? And can you see me?
Yes.
Yes? Okay. Get the sun out of our way. So this is the lowest point on the data. This is the highest point. They have to be listed in order. And then from there, you can find the middle value, Q2, Q1, and Q3. So these talk about quartiles. And even if I talk to my own children about this, you can see that this is split up into 4 equal sections, right? So this one is considered the first quartile. Okay, because that's the first quarter of the data. Then the second quartile, then the third quartile, then the fourth quartile. Okay, so Q1 is the spot where the first quartile ends, Q2 is where the second quartile ends, Q3 is where the third quartile ends, then the high point's where the fourth quartile ends. The formula for interquartile range is basically, we want to see how it spreads out around the median. So we're looking at this section here. We want to look at how close are the values to the median. So we're just looking, what is our Q3 minus our Q1? That tells us how spread out it is. Because if Q3 and Q1 are very far from the median, you can tell it's a big spread. If they're close to the median, it's a small spread, and that would make us happy. So that's the formula for interquartile range, Q3 minus Q1. Semi-interquartile range is just taking what our interquartile range was, Q3 minus Q1, and dividing by 2. Semi meaning half of that. Okay? So that's basically how we split up the measure of spread for when we're dealing with the median. Now from this comes something called a box and whisker plot. And a box and whisker plot is going to look like this. Here's the box, here are the whiskers. The whiskers go to what your lowest point is, to what your highest point is, and you'd make a scale kind of on the bottom of all your values. And then these lines that make up the box come from, the middle line is going to be your Q2 value, that line at the end is going to be your Q3, and this is going to be at your Q1. So you would put an actual scale of numbers on it, okay, for whatever your data happens to be, and then from there you would build your box and whisker plot. Okay, so I'm going to do an example where I find the interquartile range and where I build the box and whisker plot based on that. But both of these deal with the median and deal with how spread out the data is around that median. Okay, so how far have I gotten in this now? Boom. Boom. Okay, so example 1 will be good enough for us to do. I don't need to do example 2. You can look at that through here. So example 1, I was going to put that in. They list the data on the top and it's not in order. So the very first question says place the data in numerical order and find Q1, Q2, Q3, the interquartile range, the semi-interquartile range, and makes a box and whisker plot. So for this, if I write all the data in order, that makes your life much easier. 4, 4, 4, 5, 6, 7, 7, 8, 8, 2 9s, 2 10s, and 11, and a 17. So in total, how many pieces of data do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces. Okay? So once they're in order, it becomes fairly simple to figure out what's going on. Q2 has to be your median. If you have 15 pieces of data, then your middle term is your 8th term. There'll be 7 on the left, 7 on the right. So I just have to look for the 8th term. 1, 2, 3, 4, 5, 6, 7. Here is my 8th term. This is Q2. Okay, there are 7 points below, 7 points above. Now from there, I need to find my Q1 and my Q3. Well, my Q1 comes from the middle of the low half of the data. So with 7 points, the low part is, the middle is 5. Okay, it's the 4th point. There are 3 on this side, 3 on this side. Also, I'm going to have to go to the middle of my top half of the data, and that becomes my Q3. Okay, so it's just a matter of splitting things up into halves. Okay, Q2 comes from the direct half. Q1 comes from the half of the lower part. Q3 comes from the half of the upper part. So in order to find your interquartile range, once you've established what they are, you simply subtract. Okay, 10 minus 5 equals 5. Your semi-interquartile range, you just take your interquartile range and divide by 2. Not a problem. If you wanted to find range, you would just take your highest, 17, subtract your lowest, and you get 13. Okay, so an IQR of 5 means that's the measure of spread of the data around this middle point, which is 8. If you want to make a box and whisker plot from this, okay, you would set up a scale that deals with all of your data points. So you might want to go a little bit below and above. So we have to go from 4 to 17. It needs to include all of those. So you have a graph made for you, a little grid. Okay, obviously you would use a ruler and make it look much nicer. Now, in order to do this, you start your whiskers at your low point, and it must go to your high point. Before you join those points, though, with the whiskers, you should draw the box. So the box has to have lines at Q1, at Q2, and at Q3. So Q1 is 5. That means I have to have a line here. Q2 is 8. I have to have a line through 8. Q3 is 10. I have to have a line at 10. That's how I build my box. Then my whiskers just go to that point. Okay, it should go kind of right through the middle. And this is called a box and whisker plot. And what it tells you is if these are really close together, like if the Q1 and the Q3 value are close to the Q2, you know you have really tight data. There's not a lot of spread.
It looks like an alien.
It looks like an alien? I think it looks like a cat sometimes. This is what I like to do, Morgan. I like to go like this. It's called a box and whisker plot, so sometimes I like to put cat ears on it.
Whiskers.
Yeah, those are whiskers. Cat ears on it. This looks like his eyes. See? The whiskers right there. Okay, so
But
the box.
This one's long though.
Yeah, so well, that's an important point. Why is this one long? Because there's a huge outlier. Look at this value here, 17. It's an outlier sitting way over here. Okay, that's good spelling.
Not good spelling.
Liar. Sitting way over here, that's dragging this whisker farther apart. The best type of box and whisker plot that would give you the best type of data would be a tight box with little tiny whiskers. Okay? The longer the whiskers, that means you're way spread out on either end, either the high point or the low point. And a box that's way spread out says your data is not consistent. The smaller, the tighter the box, the more consistent your data is. Okay, and that's what we're looking for, consistent data, where the measure of spread is not large. Okay, the smaller the measure of spread, the better. Now, that's in reference to how big the data points are. So if you were talking about grades, an IQR of 5 would be great, because grades can go anywhere from 0 to 100. If this is talking about something that's only on a scale from 1 to 20, then this would be a fairly big spread. So you have to analyze it based on where your data is, but that's a general idea. Okay, so there is another example that talks about the same idea, that gives you frequency instead of looking at it. You can look at that on your own. It's the same idea.
Mommy?
Yes?
Is that graphing?
It's graphing, yeah.
I graphed already.
You graph too? Okay. So that's called a box and whisker plot, IQR. There's another example 3 that talks about what quartile it comes up in. You should be able to read that and have no problem. Okay. The next thing I want to do, and this is of vast importance, is how to come up with the standard deviation. Standard deviation is something you're going to be tested on at some point, and often, if we do exams, who even knows, is a question you're for sure getting on the exam. This is a massive topic in this course, not overly difficult. You just have to be able to follow a formula. And now that you're distance learning, formulas are at your fingertips at all times. So the main formulas look like this, and you have to sort of be cognizant of what's going on in terms of a population or a sample, and we're almost always going to use a population one for the most part. So standard deviation, and I write it like this a lot, standard deviation, is often represented by this little symbol, which is again a sigma.
Mommy.
But this is a lowercase sigma. Okay, and the formula for standard deviation is going to look like this. There's going to be some symbols you're familiar with. The square root.
It looks like an
does look like an A, but it's a Greek letter called sigma. The flip is up on the top. Okay, Ben's coming out. Okay, so this is a square root symbol, something you're very familiar with. Now, you also are familiar with this, which, by the way, is also a sigma, but it's a capital letter sigma.
Is that it?
Just like a capital A and a small a. Same idea. In Greek, they have capital letters, small case letters. These are the same letter, capital version, small version.
It's kind of like an M if you look at it sideways.
So this is the sum of your x values. We can call them xi values.
I'm looking for us.
Minus, that's fine, he'll find us. Minus your mean, and remember your mean could be mu or it could be x bar, squared, divided by the total number of values you have. So it seems a little bit, come in, Ben. It seems a little bit tricky, but it's not. You're going to take all your x values individually and subtract the mean from it and square them, and then add it to the next x value, subtract the mean, squared. Add it to the next x value, subtract the mean, squared. Divide by the total number of values you have, and then square root it all. Okay? None of this is out of your realm of what you can do. Can you subtract? Can you square? Can you add? Can you divide? Can you square root? Yeah, no problem. So it's just a matter of seeing it in action, and seeing it in action is gonna figure out. So this is standard deviation. Variance is simply the standard deviation squared. Okay, so once you find the standard deviation, you simply square it and you get that. If you were looking for a formula, if you square a square root, what happens? You're just left with what's underneath. So it's basically just the sum of your x values divided by the mean squared divided by n. But most of the time, if they ask you for variance, you've already calculated the standard deviation. So it's just a matter of taking whatever value you got there, which will be a number, and squaring it. Okay? They're very related values, obviously, and depending on the situation you're going to look at, one is sometimes better than the other to look at. We're going to stress standard deviation way more in this class than variance.
Standard deviation?
Standard deviation. What are you eating, Morgan?
Cornflakes. Cornflakes.
Cornflakes. Okay. So I'm going to do one part of this, an example for this, so we can see what's going on. I'm going to leave the formula up there so we can make it a little bit easier to see. So the example that we have in here is talking about a basketball team. There's actually two teams. I'm just going to do one of them on the video, and then the other one you can look at in the note. So basically, we have a basketball team with the following heights. Okay, these are the heights of the players. And this is, well, maybe I should write that down. Height is the variable we're looking at in centimeters. Okay, and our players have heights of 183, 165, 148.
Mommy?
Yes, Megan?
That looks like an S.
What does?
The 5.
Well, they'll know it's an S. Okay, 154.
They'll know it's a 5, not an S.
Oh, sorry, a 5. So we look and we say, how many players do we have exactly? So if you look at this chart, our n value here is 7. Okay, this is not a sample. This is a population. This is the entire team. There are 7 girls on the team. These are their heights in centimeters. We want to find what is the standard deviation. Well, in every calculation for standard deviation, you can't do anything until you know the mean. So this is a good opportunity to review mean. Mean is simply the sum of all of these. So you would add them all up. 183 plus 165, blah, blah, blah. You add all those up. So your last thing you're going to get is 154. Divide by 7. And we get the mean is 165 centimeters. Okay? That is going to be our average height of our team. Now, if you look at these players, there's someone that's 146 centimeters. Someone who's 183 is the top one. So there's a huge spread. So we're expecting a somewhat large standard deviation for this because we can see these are spread out. Okay? So the first step every single time, step 1, find the mean. So if you're into writing steps, this would be step 1. Always find the mean. Okay? Once you find the mean, you may want to set up a little chart, which a lot of people will do, where once the mean is established, so I'm going to write it up here, mean for this one is 165, then you can base it off the chart you already have. So I'm just going to erase this for a second. because there's certain things you need to find based on this data. So if I then add on to this chart and I say, okay, what else do I need in this formula? These are my xi values. Okay, this is really x1, x2, x3, x4, x5, x6, x7. The next thing I need to do is be able to take my x values and subtract my mean and square it. Okay, so you can do that in 2 steps if you want. The first one can be just subtract your mean, get a value. And the next one will be subtract your mean and square it. So what that means is I'm just looking at this and I'm saying, what is my x value? 183. What happens when I subtract 165? 183 minus 165 will give me 18. Do the same thing here. 165 minus 165, 0. 148 minus 165, negative 17. So I keep taking my x value and subtracting the mean. Okay, so I get negative 19, I get 16, I get 13, I get negative 11. My next column is just take this value and square it. When you square something, it has to pop out a positive. Okay, don't make that mistake. Sometimes your calculator will give you a negative value because it thinks you're doing, say, negative 17 squared. So they're doing the 17 squared and leaving the negative out front. You might have to put it in brackets. You can do whatever you want with your hair. Okay, so 18 squared, when we just look at this value, gives us 324. 0 squared is obviously 0. And then I'll just type in all of these. I've already pre-calculated them. You'll have to get a calculator out. If you don't have a calculator, you're in trouble. Find one on the internet. 256, 169, 121. Now, the key here is, this is saying take each of your x values, subtract the mean, square it. We did that. And then what does this big sigma mean again? Add all of them up. So you take this column, you add it all up, I get 1,520. To find the standard deviation now, I take my addition, that's this line, 1520, I divide by the number of terms I have, in this case 7, and I square root it. So the very last thing we have to do is do the actual calculation where we square root the sum of all of these squared, which is 1520, divided by 7. So you would do 1520 divided by 7, square root it, and you get 14.7 centimeters. Okay, that is our standard deviation in this case. Okay, that is telling you how spread out the data is around the mean. Okay, and when you actually go look at the note for this, you'll see that this very specifically points to an idea that the Falcons, this team, is very spread out because their heights have a range that's very far. Okay, the low to high is quite the range. If you look at the next team called the Ravens, most of their heights are consistent, and you end up getting a standard deviation that's way smaller. Standard deviation of 2.1. So I've analyzed this, I've written down what it all means, and from there you'll work on homework. Okay, so I would say for the next couple days you'll have enough work to do that deals with standard deviation, variance, interquartile range, semi-interquartile range, and box and whisker plot. Okay, so I'm going to post, I've posted both 3.5 and 3.6 on the same day, and then we'll move on to 3.7 and 3.8. Okay, just be aware we're in, again, this is a trying situation for all of us. I feel for all of you guys, the grade 12 marks clearly are important. We're still going to move on in a way that's very academic in this course. Whereas you might have siblings that are in grade 9, 10, or 11, and you're going to see them not doing as much work as you guys. You have to understand the weight for you guys is much greater than for any other grade. You're leaving us for the most part in June, and we have to do our best to get an accurate representation of what you know, and an accurate representation for the colleges and universities you've applied to. It's obviously not fair for anyone. I feel for you guys. I'm going to try to do my best to get us through this in the best way possible. Please continue to email me if you have questions. I am doing my best to balance having my own kids at home, having to try to get them to learn something, and try to teach you guys. So understand the situation is not good for anyone, and for the most part we want you guys to stay healthy, but we also have a responsibility to educate you. So this is going to probably last into June, so hunker down now. This is the way it's going to be, and I don't say that lightly. I would much prefer to come to school and see your smiling faces and teach you the way I know how to teach. I don't know if I'm good at this, probably not, but this is the best we can do for now. So attempt the homework. Please send me just a picture of the homework question. If you get stuck, I'll answer it on a scrap piece of paper, send it back. If you think we can talk it through, by all means, I have no problem calling you at home. Send me your phone number. I'll give you a call and we can talk it out. Okay? I'm here. I'm at home, so we're not going, none of us are going anywhere. We can't claim we're too busy because we have nowhere to go. Okay, thanks. We'll see you again.